the difference in the angular momentum of two Bohr's orbits is 5h upon 2 pi, right? H by 2 pi is also written as h bar. Now the number of all possible electronic transitions between these two orbits is all possible electronic transitions. So while doing the electronic transition, what will they do? They will emit light also. So we can say the number of spectral lines, in other words, right? So the number of all possible electronic transitions you have to calculate. Now how can you calculate this? We have a formula like the number of spectral lines is equal to n into n plus 1, and it is divided by 2, right? So students, whenever there will be electronic transition, that is the electron is moving from one level to the another energy level, there will be emission of that spectral lines. So if you are calculating the number of spectral lines, you can easily get the number of electronic transitions. Now what is this n here? Students, this n is equal to n1 minus n2, or you can say it's n2 minus n1, that is the differences between the two energy levels, right? So what is this n here? N is the difference between the two energy levels, that is n2 minus n1. So in this question, what we require? We require this n2 and n1. What are these? Now here it's given that the difference in the angular momentum of two Bohr's orbits is 5h by 2 pi. So what is the angular momentum of a Bohr orbit? According to Bohr suggested that only those circular orbits are possible whose angular momentum is integral multiple of h upon 2 pi, right? So this is the difference between the angular momentum. Can we take it as n? Let's calculate this. I'll not take it directly. Say your angular momentum mvr is equal to n1h by 2 pi, and the angular momentum for the second orbit is mvr is equal to n2h by 2 pi, right? Now the difference between these angular momentums, that is n1h by 2 pi minus n2h by 2 pi, and that is equal to what, students? It is 5h by 2 pi, right? Now what I can do is I can just take h by 2 pi common here, put here n1 minus n2, and what we will get? 5 into h by 2 pi. So this can be cancelled out, and the difference we have already got, and this is what, students? 5. I told you. Now what you need to calculate? You need to calculate the number of electronic transitions or the number of spectral lines. So that number of electronic transition will be equal to what? It would be 5 into 5 plus 1 by 2. Am I clear? So let's solve this. It would be 5 multiplied by 6 divided by 2. That is 30 divided by 2. Right? 5 6 is 30. So how many lines we are going to get here? We are going to get 15 lines. I think by mistake one of the option is wrong here. It should be 15. Right? So how many lines or the transitions will be taking place between them? It would be 15. Right? Now students, had the difference been 3, so it would have been 3 transitions. Right? Say, I'll take an example here, like if the difference between the angular momentum of 2 orbits is 3h upon 2 pi. So how many spectral lines will be obtained? Spectral lines, or how many electronic transitions will be there? How many electronic transitions will be there, students? Again, that difference you have got, N1 minus N2, or you can say N2 minus N1, you have got that difference. So that difference over here is how much? Is 3. So the number of transitions will be equal to, I'll write it here, the number of transitions will be equal to 3 into 3 plus 1 by 2, and that is equal to 3 into 4 by 2. That comes out to be 12. Right? So this is the simplest way we can do such sort of questions.